Forces and motion, lesson 11, calculating acceleration. Acceleration is change in velocity over time, and change is always final subtract initial. In our formulas, A is acceleration, measured in meters per second squared. Triangle V, and we call the triangle delta, so delta V, is change in velocity, measured in meters per second. VF is our final velocity, and VI is our initial velocity. Example 1, what is the acceleration of a horse if it goes from 3.1 meters per second west to 2.7 meters per second east in 6.2 seconds? So we are looking for the acceleration. We're told it starts at 3.1 meters per second west, so that's our initial velocity, and it's accelerating up to 2.7 meters per second east, so that will be our final velocity. And that all occurs over 6.2 seconds, so that is our time. Now before we move on, we want to make sure that all our directions are going in the same direction. So we can either select everything to go west or everything to go east. In this case, I'm going to switch everything to west. So 2.7 meters per second east becomes negative 2.7 meters per second west. I'm looking for acceleration. Acceleration is change in velocity over time. I don't know change in velocity. I do know time, but before I go on, I will have to solve for change in velocity. Change in velocity is final velocity subtract initial velocity, both of which I have, so I can substitute those in. My final velocity is negative 2.7 meters per second, and that's subtract my initial velocity, which is 3.1 meters per second. So my change in velocity is going to be equal to negative 5.8 meters per second. Now we will sub that into our previous equation. Acceleration equals change in velocity over time. So that equals negative 5.8 meters per second over the time of 6.2 seconds. We punch that into our calculator. We get negative 0.93548 meters per second squared. So our answer is negative 0.94 meters per second squared west, which we would then write as positive 0.94 meters per second squared east. Example 2. How long does it take a car to increase its speed from 2.8 meters per second north to 9.7 meters per second north if it accelerates at 3.2 meters per second squared north? So how long does it take? That means I'm looking for time. And the car is increasing its speed from 2.8 meters per second to 9.7 meters per second. So we're starting at 2.8, so that will be our initial, and we're speeding up to 9.7, so that will be our final velocity. And we're told it's accelerating at 3.2 meters per second squared north, so that's our acceleration. I'm looking for time, and the only formula that we have been given today that has time is acceleration equals change in velocity over time. I need to isolate time. Now, the first problem time has is that it's on the bottom. It's not by itself, but it's also on the bottom. And we don't want to have time on the bottom. When we isolate it, we want it to be on the top. So I'm going to remedy that by multiplying both sides by time. That way, the times on the right-hand side will factor out, and then I wind up with time on the top being multiplied by acceleration, and that's equal to change in velocity. Now that time is in the numerator, I'm going to isolate time by getting acceleration away from time. And since the two are multiplying, I will do that by dividing both sides by acceleration. When I do that, acceleration on the left will factor out. Now I have time is equal to change in velocity over acceleration. So now I just have to sub my numbers in. And delta V is equal to, we don't have delta V. So it looks like we're making a little side trip. So let's find out what delta V is. Delta V is equal to VF subtract VI. I got a final velocity of 9.7 meters per second, and I have an initial velocity of 2.8 meters per second, so I'll sub those in. And 9.7 subtract 2.8 gives me a change in velocity of 6.9 meters per second. Now I can continue on with my time equals change in velocity over acceleration. So change in velocity is 6.9 meters per second. Acceleration is 3.2 meters per second squared. Punch it into my calculator, and I get 2.15625 seconds. Corrected to two significant figures, my time is then 2.2 seconds. Example 3. What is the initial speed of a car if it is now doing 3.7 meters per second north after accelerating 2.7 meters per second squared south for 11 seconds? So what is the initial speed? Well, I'm looking for VI. So our VI is our unknown. It says, what was its speed if it is now doing 3.7 meters per second north? So if we're looking for VI, 3.7 meters per second north is the speed that it is doing later on. So that is going to be my VF. And then clearly it says accelerating 2.7 meters per second squared. So 2.7 meters per second squared is the acceleration. And we're told 11 seconds, and time is measured in seconds. Now, before we move on, we have to make sure that all our directions are the same. So we can switch velocity and acceleration to both being north or both being south. Again, there is no wrong answer. You just go with whatever you think is going to work out for you best, because it will make no difference in the end. So I've decided this time I'm going to switch everything to south. So final velocity now becomes negative 3.7 meters per second south. Now, since I'm looking for VI, the only formula today that I have used that has VI is delta V equals VF subtract VI. And VI has two problems before we can substitute numbers in. We want to isolate VI, but VI is not by itself, and it's also negative. Now, there's a few different ways that you could fix the fact that it's negative to change it into a positive. So I'm going to show you one method, the one I'd use. So negative VI means I'm subtracting VI, and the opposite of subtracting VI is adding VI. So if I add VI to both sides, then the negative VI plus VI on the right-hand side will cancel out, and I'll wind up with delta V plus VI equals VF. Now to get VI by itself, delta V and VI are adding together. So since delta V is being added to VI, if I want to move it to the other side, I am going to have to do the opposite of what delta V is doing. So since it is adding, I will subtract VI from both sides. So on the left-hand side now, delta V subtract delta V, they will cancel each other out, and I have VI all by itself, and it's equal to VF subtract delta V. So now I just have to sub my numbers in. VF is negative 3.7 meters per second south, and that's subtract delta V, which is we don't have it. So we're going on another side trip, kiddos. So I'm going to use acceleration equals change in velocity over time. Since I have to find change in velocity, I'm going to have to get change in velocity by itself. So that means I have to get t away from delta V. And I do that by multiplying both sides by t. So on the right-hand side, the t's will factor out, and I wind up with t times a equals delta v. So change in velocity equals time multiplied by acceleration, which is, well, time is 11 seconds, acceleration is 2.7 meters per second squared. I multiply them together, and I get a change in velocity of 29.7 meters per second. Now let's get back to that previous equation, because we now know delta V. So VI equals VF subtract delta V. So VI equals VF, which is negative 3.7 meters per second, subtract delta V, which is 29.7 meters per second, and that's going to give us a final answer after rounding of 33 meters per second north. Our answer came out as negative, and we chose south to be our positive direction. So since we have negative 33.4 meters per second south, we changed that to 33 meters per second north. Welcome to Mr. Sklar's Keys to Success. Number 1, make a list of variables. Number 2, make sure all directions are the same. Number 3, select the formula that has the variable you are looking for. Number 4, isolate the variable you are looking for. And then 5, substitute numbers in and solve. Do not skip these steps. If you do, it may spell complete disaster. And that's the end of the lesson. Make sure that you follow the steps. Everything will work out just fine.